So far we've seen three measures of central tendency. What are those three? Mean, median, and mode. So when do we prefer measuring what? So that choice of measure depends on our requirement. So like, when do we measure mean? So we use it when we have to take into account all the observations. Okay, and this mean has to lie between the two extremes. So mean is basically used for comparison purpose. Okay, like if I give you two or more distributions and if you want to compare between them, then mean comes in very handy. So these are the situations when you'll prefer calculating mean. Now, when do we use median? So median is used when those individual observations are not of much importance to you, but you want to find out a typical observation only. Then finding median would be more appropriate than finding mean. Then there can be some cases where you need to find out which object is used the most, or say which Netflix series is watched the most. Then you make use of mode. Okay. So I'll ask you some questions and you tell me which measure central tendency would you prefer to use for that particular purpose. So if you want to see which TV show is most popular, then you will calculate the maximum frequency, right? So then you need to choose mode. Okay. Now my next question is, if I give you a class and I give you the marks of a class, I ask you tell me the average marks of the class, then what would you do? You will find the mean. Now, if I ask you a question like find the average wage in India, wage means salary. So find the average wage in India. So in that case, don't get carried away by looking at the word average. So it has to be mean. In this case, median calculation would be much more appropriate than calculating mean. The reason is that here we do not really care about the individual wages. We just are looking for typical observation. So that is the average wage. So we will prefer using median rather than going for mean. So then we have a relationship between these three measures of central tendency: median, mode, and mean. This is a relationship which is empirical in nature. Empirical means this relationship has been observed in many cases. So by observation, we are giving this relationship, which is 3 median is equal to mode plus 2 mean. This comes in very handy, trust me. For example, if I know for any data, I just know the median and mean, and I don't even give you the data, then how will you go about finding the mode? If data is not there with you, it will be very difficult to calculate the mode, and then this relationship can be very useful. So let me give you an example. Let me provide you a data of heights of 5 persons. Okay. So let's say the heights of those 5 persons are, so I give you a person with height 122 centimeter, and a slightly taller person with height 124 centimeter, then 144 centimeter, 155 centimeter, and the other person is of the same height, 155 centimeter. So these are your 5 observations: 122, 124, 144, 155, 155. All of them are the heights of 5 persons in centimeters. Now here I give you that the mean height, I give it to you, is equal to 140 centimeters. Okay, you can calculate it yourself also. You add all the observations, you'll actually get 700, and the number of observations will be 5, so you'll get 140 centimeters as the mean height. Now I give you the median. You look at n is 5, so that is odd. So this is ungrouped data, right? I am not giving any class intervals. So you will make use of which formula? For median, n plus 1 by 2th observation. That will give you 5 plus 1 by 2, that is 3rd observation, which is 144 centimeters. So the median height is 144 centimeters. The mean height is 140 centimeters. Now clearly from just the observations, you cannot make out the mode. Okay, it will be a bit difficult basically, I mean to say. So how do you do that? Then you make use of this formula. So you can say that mode is equal to 3 median minus 2 mean from here. So what is the median? That is 144. So 3 into 144 minus twice of 140. When you solve for this, you will get 432 minus 280 is equal to 152 centimeters. So this is just an example telling you how we can make use of this relationship: 3 median equal to mode plus 2 mean. Then we have graphical representation of cumulative frequency distribution. Now we make use of cumulative frequency distribution specifically for median, and we saw that the table having XICF values is called the cumulative frequency table. Now this table can be used to plot a curve also, and that curve is called the cumulative frequency curve or an ogive. Okay, it's pronounced like ogive. So here, how do we make this curve? To make any curve, we take your graph paper. So we have a y-axis and we have an x-axis. So on the x-axis, what do we have to take? The upper limits of the class intervals. Okay, so the moment I say class intervals, it means we're going to deal with grouped data over here. The data will already be in the form of class intervals. So you'll take the upper limit. So for example, if I give you 10 to 20, 20 to 30, then 20 and 30 would be the upper limit. So you'll have those upper limits over here. Okay, and corresponding to those classes, you will have the corresponding your cumulative frequencies. Okay, so on the y-axis, we are having these cumulative frequencies. On the x-axis, we are having upper limits. So here I'm having upper limits 10, 20, 30 going on till 100, and these are my corresponding cumulative frequencies. So like for upper limit 10, my cumulative frequency is 5. Okay, so this is my point that I plot here. Then for upper limit 20, my cumulative frequency is 8. For upper limit 30, my cumulative frequency is 12, so on and so forth. And then you join these points. Now, this is not at all a straight line. It's a freehand curve. Okay, so you better make it smoothly. Make it in the form of, don't make use of any ruler. Just do it freehand. Okay, otherwise your marks will be deducted. So the ogive that we just saw was of less than type. And now we see an ogive of more than type. So less than type was something like this. Now more than type will look like this. Okay, so here at the initial lower limit only, we take the sum of all frequencies. So this will start from here, that's why. Okay, whereas in less than ogive, we see that we get the maximum cumulative frequency towards the last class, right? So that's the total opposite in this case. So here you have the lower limits. So this is the difference. Okay, there you are having the upper limits, and here you are having the lower limits. The y-axis remains the same. You are taking the corresponding cumulative frequencies. So here for the lower limit 0, we are having cumulative frequency near about 50. Then for 10, we are having near about 48. For 20, we are having near about 45. So then we join all these points. So do we make use of a ruler here? No. We do it freehand by just joining the points, okay, with a pencil like this. Whatever your curve you are getting, just obtain that. So now I told you that whenever we talk of cumulative frequency, just hints at calculating median. So ogive is also graphical representation of the same. So can we calculate median using ogive? Yes, the answer is yes, and in fact there are two methods to do so. Okay, let's see the first method. The first method is that you make your ogive. So just by looking at this graph, tell me, is it of the less than type or is it of the more than type? It is of the less than type. So here, if I give you a cumulative frequency table, what do? For less than type of table, you look at the last cumulative frequency, you call that n, and then you do n by 2, and then you look for the observation corresponding to this n by 2th cumulative frequency, and that's how you get your median class, and then you use the formula for group data. So here also you do the same thing. You can calculate your n over here. Okay, so the n over here is 53. So n by 2 will be 26.5. So locate this point 26.5 on the y-axis. Draw a line through this point parallel to x-axis. Okay, this is parallel to x-axis, and then keep on drawing this line till it meets your ogive. So the point where it meets the ogive, mark that point, and from that point drop a perpendicular on the x-axis. Now the point where this perpendicular will meet the x-axis is your median, and if you find out on your graph sheet, this median will turn out to be 66.4. Okay, so this is one method. Just plot n by 2 on y-axis, corresponding to that find out the x coordinate, and that's how you will get your median. Another way is that you plot both the ogives, that is less than type also and more than type also. So here obviously the scales can be different for the two ogives. So for the less than type, we take the upper limits here, and the same become the lower limits for the more than type, but on the y-axis you'll have cumulative frequencies only. Now it's very important that you label your axes always. You always mention the origin and you write the scale on the top right hand corner. So scale would depend on whatever scale you are taking. So here we will be taking 10 units on x-axis is equal to 1 unit. Okay, and then here 10 units on y-axis is equal to 1 unit again. Okay, so so here we make the two ogives. So clearly you can make out which is more than type and which is less than type. So you tell me this one first of all, this one that I'm calling by the Roman number 1. Is it of the more than type or less than type? It is of the more than type. Okay, a more than type ogive always starts from a higher frequency. Okay, because the first class will have sum of all frequencies as the cumulative frequency. Here it will just be the opposite for the second one, and this is an ogive but of the less than type. So now this is very simple. You make the two ogives, look for the point of intersection of the ogive and look at the x coordinate of that ogive. So in this case also your median becomes 66.4, so that will be the x coordinate of the point of intersection of the two ogives. Let's understand that by example. So you've been given annual profits earned by 30 shops of a shopping complex. So you've been given profits. So this is a cumulative frequency table, but it could be of two types, less than type or more than type. So identify which type is it. This is the more than type. You can make out by looking at this column. So this column is written in words right now. We can write it in terms of class intervals as well. And you have been given a number of shops. But this is not any normal frequency. This is your cumulative frequency, that too of more than type. So first of all, from this cumulative frequency of more than type, we'll find out the normal frequencies. So you write the profits in the form of class intervals. You write the cumulative frequency more than type, and then you write the number of shops. How do you do that? So the first frequency will be 30 minus 28, that is 2. The second frequency will be 28 minus 16, that is 12. Then the next one will be 16 minus 14, 2, 14 minus 10, 4, 10 minus 7, 3, 7 minus 3, 4. We are basically moving in the backward directions. Normally, we are given the frequency and then we find out the cumulative frequency. Now you go in the reverse order. So now if you've obtained the frequencies, size, can you get the cumulative frequency? But you will be saying that we've already given this, we've already been provided this in the question. Well, this cumulative frequency is different. This is for the more than ogive and this is for the less than ogive. So how will you get that? You can look at the frequencies itself. So it will be 2 for the first one, then it will be 2 plus 12, 14. Then it will be 14 plus 2, 16, 16 plus 4, 20, 20 plus 3, 23, 23 plus 4 will be 27. Okay. So now you need to plot the ogives. So how would you do that? You will have your x-axis, you will have your y-axis, okay? And here you have your origin. So what you will do is you will write here 5, 10, 15, okay? So basically, if you're plotting a less than ogive, you'll have the upper limits over here. If you're having the more than type, then you will have your lower limits of those classes here. And the y-axis will always have the cumulative frequencies only. So this is the cumulative frequency of more than and this is less than. And here we've plotted some, so here we've made our x-axis and y-axis. Please do label it, and now we'll start plotting the points. So we see that first we are having this cumulative frequency 30. When the lower limit is 0, then we are having it as 28. When it is 5, so it will be over here. Then for 10 we are having 16, so it will be here. Then we are having it as 14. For 15, so it will be here. Then for 20 we are having 10. By 20 I mean the lower limit 20, okay? So this is 10. Then we have 7 for lower limit 25 and 3 for lower limit 30. So just join them. Alright, so once you have joined them, now what you need to do is you need to look at the cumulative frequencies of less than type. So this is for upper limit 10, this is for upper limit 5, this is for upper limit 10, 15, 20, 25, 30 and 35. So for lower limit 5 it is 2, so this will be 2. For 10 we are having 14. Then for 15 we are having 16. Then we are having 20, so it's 20 again. Then we are having for 25 we are having 23. Then for 30 we are having 27, and for 35 we are having 30. So basically if you join these ogives, then okay, so basically you will be getting an ogive like this. Okay, it will look something like this and then this. So basically you will get a point of intersection here, and if you look carefully, this point of intersection will be close to 20, and if you do that exactly, if you are making use of a graph paper, you will get the exact value. So that value should turn out to be the median, and that will be 17.5 in this case. So which method did we use here to calculate median using ogives? We looked for the two ogives more than and less than type. After plotting them, we looked for the point of intersection, and that gave you the median. So with this, we come to an end of this chapter. Now it's time for a quick revision. What do we mean by measure of central tendency? It refers to a value which helps you making sense of your data by hinting at some central value of that data set. So we discussed three measures of central tendency, if I'm not wrong. So quickly tell me those three measures, what were they? So they were median and mode. So now everything in statistics starts and ends with data, and this data can be of two types. What are those two types? Ungrouped and grouped. How do we identify? So ungrouped data will not have any class intervals, but grouped data will have class intervals. What do we mean by mean? Mean in simple words is average. So to calculate mean for ungrouped data, we make use of the direct method, which is summation fi xi upon summation fi. So you look at the observations, multiply them with their frequencies, and then add them up. So the symbol stands for summation, and then you divide it by the sum of all frequencies. But for group data, there are three methods to calculate mean. So the first one is this only direct method. So here, what are the columns? We have xi, we have class interval first of all, because this is group data. How do we get these xi values then? They are your class marks. It doesn't mean the marks of a class, it refers to the midpoint of a class, because it's based on the assumption that your frequency is centered at the middle point of this class interval. Then we have fi, and then we calculate fi xi. We take sum of fi and fi xi. Then we divide the two using this formula. That's how we go about calculating mean using direct method. Then we have another method, which is the assumed mean method. What do we do here? We have an additional column over here, which is di. Di is called deviation. What is the formula for di? That is xi minus a. What is this a? A is the assumed mean. This assumed mean is any observation in the middle. So any class mark in this case, and then you calculate fi di. So what is the formula to calculate mean by this method? X bar is equal to a plus summation fi di upon summation fi. Then how do you calculate mean by one more method? That method is step deviation. So what was the formula here? X bar is equal to a plus summation fi ui upon summation fi into h. What is h? H is the class size. So lower limit is subtracted from your upper limit. Then what is the another column which we'll have for this particular method? We'll have ui. Ui is what? Di upon h, and then we will have fi ui. So now you should be able to answer why we are grouping data, because if we are having enormous amount of data, then we need to have some sort of organization in it to simplify our calculations. And then why do we move from direct to assumed and assumed to step deviation method? Because that simplifies the product calculations which we are having. So it's easier to calculate fi ui than fi di than fi xi. So then we know what x bar is. How do you write d bar and how do you write q bar? This is summation fi di upon summation fi, and this is summation fi ui upon summation fi. After having discussed mean, we moved on to mode. Mode refers to maximum frequency calculation. So how do you go about this? You look at the class which is having the maximum frequency, and we call such a class as modal class. And then for grouped data, we are going to have these class intervals, and there we had a formula. Mode is equal to what? L plus f1 minus f0 upon 2f1 minus f0 minus f2 multiplied by h. H was the class size of that modal class, L was the lower limit of the modal class, f1 was its frequency, f0 was the frequency of the preceding class, f2 is going to be the frequency of the succeeding class then. So this is how you calculated mode. For ungrouped data, how do you calculate mode? So to calculate mode for ungrouped data, you just looked at the observation, which is repeating the maximum number of times. Alright, so then we discussed median. Median refers to the middlemost observation. So for ungrouped data, what was the procedure? So first of all, you have to arrange in ascending order. Then you have to calculate n, that is the number of observations. Then what happens is, if n is odd, you look for n plus 1 upon 2th observation. And what happens if n is even? You take the average of two observations. Those two middle observations are n by 2th and n by 2 plus 1th observation. Very good. Now this was for ungrouped data. How do we calculate median for grouped data where class intervals are given to us? We calculate cumulative frequencies. So we get a cumulative frequency table, xi, fi, cf. So this was a frequency distribution table, and xi, cf columns give you a cumulative frequency table. Now this could be of two types. The two types were less than type and more than type. So if frequencies were given to us, we just added them up. We got the cumulative frequencies for less than type. We looked at the last cumulative frequency, that was n. We divided it by 2, and then we looked for the corresponding median class. Once we had the median class, we made use of the formula for median, which is equal to L plus n by 2 minus cumulative frequency upon f into h. So h is the median class, the class size of the median class, L is the lower limit of that class, f is the frequency of that class, and cf is the cumulative frequency of the succeeding or the preceding class. After having understood mean, median, mode, we also saw an empirical relation between the three. What was that? That was 3 times median is equal to mode plus mean? No, mode plus 2 mean. Okay, so then what do we call a cumulative frequency curve, by the way? We call it an ogive. Now if it is a curve, we'll have an x-axis, we'll have a y-axis. So what do we have on x-axis? So this ogive could also be of less than type and more than type. So for less than type, here you have the upper limits. For more than type, here you have the lower limits. And here you will always have the corresponding cumulative frequencies. Now can we calculate median using ogive? Yes. By how many methods? 2 of them. One method that we even employed in an example was that you make the 2 ogives for the more than type, for the less than type, look for the point of intersection, and its x coordinate will give you the median. But there was one more method that you spot n and then n by 2 on the curve itself. So if I give you a less than type ogive, you look for n by 2. Corresponding to that, you find the point on x-axis. The x coordinate is going to again give you the median. So that's it for this chapter. Thank you.